All right, just getting started on our single replacement reactions. Once again, our learning target's the same as it was for the other ones, to classify the types of chemical reactions. So our success criteria, once again, to be able to balance a chemical equation, that's the final part of the whole entire process, to describe/identify a single replacement reaction, and finally, we got two more, not finally, to predict a single replacement reaction and to use the activity series to predict whether a single replacement reaction occurs. So we're going to bring that activity series into play also. So here is our very first example that we are going to do. And these are different from the ones that you had on your video. So you might want to copy these down into your notes. Sodium oxide plus calcium. Sodium oxide plus calcium. Well, how are we going to start this process out? Well, we're going to come back to this guy right here. And this goes along with your outline. So I'm looking at your outline. I'm looking at the 5 different types of a single replacement reaction. So as I'm looking at these, do I have a metal and an aqueous salt? Well, calcium's definitely a metal. Sodium oxide is an aqueous salt. So it could be a single replacement one. Do I have water? Do I have water in this equation? No, I do not. Do I have a metal and an acid? There wasn't an acid there. Do I have a halogen and an aqueous salt? Well, remember our halogens, group 17, I didn't have one of those. Do I have a metal oxide? Yes. Do I have hydrogen? No. Okay, so as I'm looking through these 5 different types, the one I am going to be dealing with is single replacement number 1. So I have a metal and an aqueous salt, and what I'm going to create is a new metal and a new salt. So I'm going to come back. Now and say, all right, sodium oxide plus calcium. Now, it is going to yield a new metal and a new salt if I get that replacement. Okay? And what do I mean by that? I need to check my activity series. I need to check my activity series because it says at the top of my single replacement on my outline, must use activity series and ionic reactants must be aqueous or molten. So what I am going to do is I need to check to see if my calcium is higher than my sodium. My calcium's got to be higher than my sodium. I'm just writing down there, this is a single replacement number 1. My calcium's got to be higher than sodium. Well, I go back to my activity series. Is my calcium higher than my sodium? Yeah, just barely, but just barely doesn't matter. It needs to be higher. So calcium is more active. So this is going to occur. So what am I going to get? Well, I'm going to get a new salt, which is calcium oxide, and a new metal, which is sodium. Remember, calcium's a 2+, oxygen's a 2-. So those equal out. So, am I finished with this right here? Am I finished? No, I need to do what? I need to balance this So I need to put a 2 here in front of the sodium. Now I should have that balanced, correct? So basically, in a single replacement, I'm replacing, in my reactants, I'm replacing a single thing. Here is my second one. Iron plus copper 1 chloride. So I have iron plus copper 1 chloride. So as I go through my list, once again, as I go through my list, do I have a metal and an aqueous salt? Well, yes, I do. Do I have an active metal and water? There's no water there. Do I have a metal and an acid? I don't have an acid there. Do I have a halogen? Nope. Do I have a metal oxide and hydrogen? Nope. So this particular one is also going to be a single replacement number 1. So I make sure that I write out my single replacement number 1. Then I have to go to my activity series. And is iron higher than copper? Well, I'm looking at it right now. I see iron, and copper's all the way down here at the bottom. So is iron higher than copper? Yeah, it is. Iron's higher than copper. So does iron have the activity, the strength to replace copper? It does. So this reaction will occur. So I go back, and I know that my iron will replace my copper. Now, here's the point, too, because I know iron is multivalent. So could I have 2 different answers for this particular one? Yeah, I could. I would have to test whether I have iron 2 or whether I have iron 3. So you could put either one of those on right now, because we're not doing a test. We don't actually have the chemicals out in front of us. Okay, but you remember, well, I don't know if you remember, we did do tests for this, whether we had iron 2 or iron 3. When we added little drops, remember we were looking for a blood red color or a dark blue color. Okay, so we actually have performed these tests. So iron, I'm just going to go with iron 3 chloride. So I'm going to have my iron 3 chloride, and then I'm going to have my copper. Now, I definitely need to balance this up. So I could do so by placing a 3 here. That balances up my chlorines. I could place a 3 here. That balances up my coppers. Now, do I have a balanced chemical equation? Yes, I do. Yes, I do. Any questions over that one? Here's my next one. Chromium is reacting with steam. Now, ladies and gentlemen, what is steam? Well, steam is just simply water in the gaseous state. So as I'm looking back at my reaction types, I know there was one that was dealing with water. You see that one? That number 2 right there. Okay? Since they give you that information, I would. Okay? I would write that it's a gas there since that was given to me, because it's definitely needed on the activity series. All right? Excuse me. So now I'm looking at this, and I say, okay, do I have an active metal plus water? So this is a single replacement number 2. So I come back here, I put, yes, this is a single replacement number 2. Now I have to check my activity series. Okay? There are different parts for this particular one. I see right here I see a line that says it reacts with cold water, liberating hydrogen gas. I see a line here that says it reacts with steam, liberating hydrogen gas. So I look to see where chromium is. And here's chromium right here. Okay? Is chromium above that line that says it reacts with steam? Absolutely. Okay? If it were up here where sodium, calcium, strontium, if it were up here, no, it wouldn't, because that has to be cold water. The steam would not count. But since chromium is down here, it reacts with steam, liberating hydrogen gas. So basically, what I have going on here, coming back, my chromium is going to react with steam. So it says an active metal plus water will give me a metal hydroxide and hydrogen. Well, what's my metal hydroxide going to be? What's my metal? Chromium, right? So once again, this chromium here could take different charges. Okay, it could take different charges, because looking at my periodic table, chromium has a 3, 6, and a 2. I'm just going to say that I have chromium 2. So I'm going to put chromium 2 hydroxide. Remember, hydroxide's a -1. Chromium 2 hydroxide, and it's going to also give me hydrogen gas. Remember, though, that hydrogen is indeed a super 7. Hydrogen is indeed a super 7, so I need to have 2 hydrogens to go along with that. So as I'm looking at that, that pretty well looks to me like I need to balance. I don't have this balanced yet, do I? Now, what if I put a 2 right here? Do I have that balance now? Yeah. Yeah. Now, how would this have been different if I used a different chromium? Well, Cr plus H2O. If I had chromium 3, I would have this. So now I'm going to have to balance that out a little bit differently. Okay? So I'm not going to go through, I don't know if we have enough time to do everything. I'm not going to go through and balance out that skeleton, but I just want you to realize what would have been different if I would have used a different chromium. Our next example, zinc plus hydrobromic acid. Zinc plus hydrobromic acid. I've got my zinc here. Hydrobromic acid, IC 1 or 3. With the hydro, that is bromide. So I have HBr. Now, once again, the first thing that I need to do is determine what type of a single replacement reaction I'm dealing with. So I come back here and I remember in my mind that there were one of these that was dealing with an acid, correct? So I look and say, okay, here it is. It's number 3. Number 3 states a metal plus an acid will yield a salt dissolved and bubble off hydrogen gas. So I'm dealing with the single replacement number 3. So identify, yes, I do know what single replacement reaction I am dealing with. Now I need to go to my activity series. Okay? And I can see that hydrogen is boxed in. I have a little pink box here with hydrogen right here. Now, the line there says reacts with acids liberating hydrogen gas. So all of these things under, all of those under that box of H will not react with an acid. Those will give you NRs. Okay, what was I dealing with? Well, my metal was zinc, right? Is zinc above that line? Is zinc above that line? Yeah. Yeah, zinc's above that line. So will zinc replace that hydrogen to give me the hydrogen gas? Absolutely. So as I come back, my zinc is going to replace my hydrogen. So I'm going to get zinc bromide as my salt. Zinc's a 2+, bromine's a 1-. So that's going to give me zinc bromide. I'm going to need 2 of those bromides. Once again, because if you remember, like I just said, zinc is a 2+. I'm driving me crazy here. Zinc is a 2+. Bromine is a 1-, so I need the 2 bromines. So it gives me zinc bromide, and it's also going to give me hydrogen gas. What do we know about hydrogen? It's a super 7. It's diatomic, so I need 2 of those. So am I balanced out here? Am I balanced out? Nope. Now am I balanced out? Yep. Now I'm balanced out. Now this final one, people, this final one is the toughest of the single replacements. Why is it the toughest of the single replacements? Because we just have to recognize. We have to recognize. Bromine. Br. Bromine is definitely a super 7. Sodium iodide. Sodium's a 1+, iodine's a 1-. So, bromine plus sodium iodide. This, ladies and gentlemen, is one you have to just recognize. This is a single replacement number 4 because bromine is a halogen. So the problem with this, where this is different, is bromine here is not going to try to replace sodium. Bromine's going to try to replace iodine. A halogen replacing another halogen. That's what makes this a little bit more confusing, because we're replacing the halogens. All the other ones we've been replacing metals, right? This one's not. Excuse me. This is going to replace the nonmetal. So I have a different section of my activity series to look at. And that different section is right here, okay? Is right here, this whole halogen activity series. So I have to look to see if bromine is higher than iodine. Is it? Yes. So will bromine replace iodine? It will. It will. So as I come back here, I know that my bromine will replace my iodine, so it's going to give me sodium bromide, and it's also going to give me iodine. But remember, iodine, once again, iodine is a super 7, correct? Iodine is a super 7. And you're going to see that all of these halogens are super 7, right? So that's something to recognize with this when we're dealing with those. Yes, indeed, we got super 7s here. Now, this guy is not balanced yet because I need to have 2 iodines. And then when I put a 2 in front of the sodium bromide, this will indeed balance this out.